Hi guys. Smarty here. From the channel Smarty Stranger. In our previous video, Conversion Instructions, Lesson 07, we learned about basics of conversion instructions, their different types, and also study their working concept via inserting them in TIA Portal. If you have not seen our previous videos, then go to our channel, Smarty Stranger, and take a look on our previous videos. Today we will try to learn about our next instructions family, which is Program Control Instructions. Program control instructions are used to enable or disable a block of logic program, or to move execution of a program from one place to another place. First members of this family is MCR instruction, a short name of Master Control Reset. It clears all set non-retentive output rungs. Between the paired MCR instructions, two MCR instructions are used to perform the function. One for the start of MCR zone, and another one is to end the area. This instruction is also called a soft emergency stop. Second member of this family is Jump instruction, JMP. This instruction is used to interrupt the linear execution of the program and resume it in another network. Or we can define it as the jump instruction is used to jump over certain program instructions when certain conditions exist. Some PLCs use skip instruction, which is same as jump instruction. Third family member is label. Actually, jump and label instructions work together. Jump is used at starting point and label instruction is used as a destination or target point. When the jump coil is energized in used program, all logic between the jump and label instructions is skipped or bypassed, and the remaining program after label instruction remains active. Fourth family member is Jump N instruction, JMPN. The jump N instruction is used to jump over certain program instructions when input is 0. Working concept of this instruction is same as jump instruction. Means when condition at start of jump N instruction is 0. It skip the part from starting of this instruction to the target label. Another family member of this family is Jump List. You can use the jump list instruction to define several conditional jumps and continue the program execution in a specific network depending on the value of the K parameter. You define the jumps with jump labels, which you specify at the outputs of the instruction box. The number of outputs can be expanded in the instruction box. In CPU S7-1200 you can declare up to 32 outputs. Similarly in CPU S7-1500, a maximum of 256 outputs could be declared. Our next family member is Switch or Jump Distributor. You can use the switch or jump distributor instruction to define multiple program jumps to be executed depending on the result of one or more comparison instructions. You specify the value to be compared in the K parameter. This value is compared with the values that are provided by the various inputs, and result will be shown via comparison on output pins. You can select the comparison method for each individual input. So guys, let's insert these instructions in TIA Portal and study their behavior via live simulation. Listen guys, in industry you will deal with complex logic and different types of signals. But here we will use simple method to explain you the working concept of these instructions. We hope, after learning you will be able to make programs and play with different complex signals. Open your software. Wait until starting of software. Create a new project, which we have already created. Open the project view. First define some tags. Here you are seeing, we have defined different types of tags for inputs and outputs, which are bool type, integer type, and some are real types. Okay, move on programming page. Here we will insert some of program control family members. First we insert jump instruction in network 01. We know that this instruction is used to interrupt the linear execution of the program and resume it in another network. In network 02, we are going to make a simple logic. Since jump and label instructions work together, so we also insert label instruction in network 03. Jump is used at starting point and label instruction is used as a destination or target point. Attach tags to the used instructions in rung. Now we are going to name a label as CAS01. Attach label name with jump instruction. Now we are going to download the program in simulator. Save program. Download in simulator. Run the simulator. Click on monitor on. OK, now we check the behavior of jump instruction. When we energize the input 01, jump instruction executed. It will bypass network 02 and shifted the program execution to network 03. Again, check when we de-energize the input 01 in network 01. Network 02 is enabled, and program can be executed in this network. Again, check when we energize the input 01 in network 01. Network 02 is disabled, and program cannot be executed in this network. When we energized the inputs in network 02, nothing happened, but input commands are saved in memory. When we de-energized the input 01, network 02 is enabled and saved input commands are activated. OK, now we make another network 04 and make some simple logic. Attach tags with input and output. Download the program. Run the simulator. Consider network 02 is active and program execution is possible. When we activate jump instruction in network 01, it will bypass the network 02 and move the program execution in network 03. Network 04 is also operative in this condition. When we de-energize the jump instruction, network 02 will be in operative condition, and execution could be possible. OK, now we will check the behavior of jump list instruction. Via using this instruction, we can define several conditional jumps and continue the program execution in a specific network depending on the value of the k parameter. Here we will make 3 labels. Insert 3 labels in 3 different networks. Define some name to each label. For example, CAS01 to label 1, CAS02 to label 2, CAS03 to label 3. Attach these labels with jump list instruction. Means this instruction will decide according to the parameter on k input. Make simple logic in all networks. We are making simple logic to understand you. In field you will deal with complex logic, but you don't need to worry. Attach tags to the used instructions in rungs, which we have defined before. Try to make simple understandable tags. Save the program. Download in simulator. Wait until completion of download. Run the simulator. Click on monitor on. OK, now we check the behavior of this instruction. Check when value at k input is 0. Ca01 is active, and all other networks are also active. Means execution of all program is possible. Check. When we apply 1 at k input, network 02 is bypassed. Program execution is shifted to network 03. When we try to energize network 02, it is not possible. Network 03 is in working condition. In this condition network 04 is also in operative condition. Check when we apply 2 at input K, network 02 and 03 are bypassed. And program execution is shifted to network 04. In network 4, we are able to make execution. We can make on or off the switch. You are seeing that network 02 and network 03 are not functioning. But when we apply 0 at K input, all networks are active. So guys, you see how jump list instruction behaves? Okay, now we insert switch or jump distributor instruction. We studied that jump distributor instruction is used to define multiple program jumps. Its execution depends on the result of one or more comparison instructions. Select data type. Insert an integer tag at K input. Here you see different comparison options are available. Equal to, less than, greater than, less than greater than, and etc. Here we are applying 3 comparison tests. Now we make 3 networks, which will work according to defined comparison result. In network 2, we are inserting one normally open contact and a coil. In network 3, insert a normally open and a normally close contact, and a coil. In network 4, insert a normally open contact, an invert instruction, and a coil. In network 5, we are inserting 2 normally open contacts in parallel, and a coil. Now we are going to insert labels in each network. Define a distinct name to each label. For example, we are giving name like CAS01 to network 2 label, CAS02 to network 3 label, CAS03 to network 4 label, CAS04 to network 5 label. Attach names of these labels with switch instruction. Now we are going to attach tags with all inserted instruction in network 2 to network 5. Attach a separate tag to each instruction to understand easily. Save the program. Download in PLC or simulator. Run simulator. Click on monitor on. Here you are seeing value at K is 0. And CAS01 label is active. CAS01 active means from label CAS01 to CAS04. All networks are enabled and are in working condition. No any network is bypassed. Here you are seeing that we can apply high or low signal on all inputs in all networks. When we apply value 15, consider here, 15 does not fall in any comparison test. So instruction enable the 4th output else label CA04. Network 02, 03 and 4 are bypassed. Only network 05 is enabled. Now we are applying value of 20 at K input. Instruction compares the input with defined limits. Here you are seeing that it enables the second output CAS02. It means execution of program will start from network 3. And network 2 has been bypassed. Here you are seeing that we can apply high or low signal on all inputs in all networks, except network 2. Now we are applying value of 30 at K input. Instruction compares the input with defined limits. Here you are seeing that it enables the last label CAS04. It means execution of program will start from network 5. And all networks between them are bypassed. Check when we apply 51 on K input. Third comparison test passed. 51 is greater than 50. So, network 02 and 03 are bypassed. Here you are seeing that network 04 and 05 are in operative condition. But network 02 and 03 are not in operative condition. When we apply 100 on K input, label K03 activated. Network 02 and 03 are bypassed. So guys, now try yourself to insert other instructions. We hope now you are ready to insert and play with any instruction in program control family. In our next video, Lesson 09, we will discuss about word logic instructions. So for more informative videos, stay on channel. Keep watching our videos. Thanks for watching.